If you want to learn something about the formation of planets, stars, and even whole galaxies, then you need to look in the infrared. That's where heat radiation comes from.
From the stratosphere, you're above most of the water vapor in the Earth's atmosphere, and water vapor screens out infrared radiation. If you're in the stratosphere, you're almost as good as a space telescope.
With SOFIA, we'll be able to look through the dust and gas right to the core of where the stars are forming, and we'll be able to make a census of how many stars are forming, also the material that is going onto the star to form it, and ultimately what actually goes into the star.
SOFIA is the Stratospheric Observatory for Infrared Astronomy, and it's a general purpose observatory. Like any observatory, SOFIA has a suite of instruments that can be mounted on the telescope. The suite of instruments being built for SOFIA are able to study radiation all the way from optical wavelengths through the infrared out to sub-millimeter wavelengths.
We will have 3 instruments when we start SOFIA: HIPPO, an occultation photometer, flight cam, a near-infrared camera and spectrometer, and Forecast, a mid-infrared imager and spectrometer.
If you look at a region that is composed of a star or many stars, but these stars are entirely shrouded by a cloud of dust, the dust is so thick that the optical radiation does not come through. What we're able to do with Forecast is that we're able to see the infrared radiation that's being radiated from the dust around these stars. We can measure the temperature of these clouds of dust, and then we can actually then tell you the components of the dust.
HIPPO is an optical instrument, unlike all the other instruments or infrared instruments. It's specifically designed to observe time variable events.
The 2 instruments, HIPPO and FlightCam, can be mounted on the telescope at the same time. And we use a special mirror that splits the visible light, sends that to HIPPO, and then redirects the infrared light to our camera. So we can take visible light and infrared light pictures at the same time of the same field.
HIPPO and FlightCam on SOFIA can make what's called an occultation measurement, where a planet goes in front of a star, blocks the light from the star, and you find out information about the planet, like the size of the planet, whether it has an atmosphere, and whether it has moons around it. This is very important information that cannot be obtained any other way, and SOFIA plays a critical role in trying to understand our solar system.
What we want to do is understand who we are, where we are, and where we've come from. The greatest discoveries that SOFIA will make, there's no way to anticipate. But the way to go in that direction to exciting discoveries is to make as versatile an observatory as you can, and that's what we've got here.